Okay, so working with these multi-stage experiments, you need to know these definitions of knowing if events are independent of each other or if they are dependent on each other. So independent events are events in which outcomes of one event has no influence on the outcome of a second event. So for example, if you roll a dice and then flip a coin, what you got on the dice has no effect on what you're going to get on the coin. Those would be independent events because they don't affect each other in any way. Dependent events are events that are not independent. So if you have that bowl of candy and you take a piece out and you don't put it back, the second draw is dependent on what was taken on the first draw. Those two events would be dependent. And so we're just going to talk kind of basically about some events, just general events, and decide whether they are independent of each other or whether they are dependent of each other. Another note I have for you here, anytime we do an event that is not replaced, that's going to be dependent. Just like, if I have a drawer with socks and I take a sock out, like I just randomly pull a sock out, when I go in to pull the next sock, the probability of what I get has changed depending on what I got the first time I reached in and grabbed a sock. It's because the first sock was not replaced. Dependent events, they can go on as many stages as the problem allots for, but anytime something is not replaced, that's going to be dependent. Events where things are replaced are independent, because if we have that bowl of candy, we take a piece out and then we put it back and it's back to its original state, the probability has not changed at all. The next draw is completely independent of the first draw. So in these next few examples, we're just going to have general examples and we're going to decide whether the events are independent of each other or dependent on each other. So selecting a king from a deck of cards and not replacing it, then selecting a king. So when you have that deck of cards and you pull the king out, the deck of cards no longer has 52 cards in it, it has 51. And all the probabilities have then changed. And so your second draw, because it was not replaced, is dependent on what you got on your first draw. So these two events would be dependent. Tossing a coin and getting a head, then rolling a dice and obtaining a 3. These two events would be independent because one does not affect the other. Practicing the piano and then becoming a concert pianist. And I kind of threw in a different type of example. But obviously, when you practice, you get better. And so becoming a concert pianist is dependent on how much you practice. And so these two events are dependent. Now we're going to go ahead and work a few more probability problems. So we have 3 boxes. One box has the letters M, A, T, and H in it. The second box has an A, an N, and a D in it. And then the last box has the letters that spell the word history. So we have 3 separate boxes, and in each box we have 3 different words. And so these are just separate letters within these boxes. So question A says, from box 1, so we're only looking at box 1, 3 letters are drawn one by one without replacement, which is key in working this problem, and recorded in order. What is the probability that the outcome is an H, then an A, then a T? So spelling hat. So I'm reaching into box 1 only, and I'm going to take a letter out, not put it back, take another letter out, not put it back, take another letter out, and I want the outcome to be hat. So let's see what the probability of that happening is. So we want the probability of getting an H, then an A, then a T equals. So I'm taking out a letter, a letter, a letter. And this is just to help you visually, me drawing these little marks right here. So I want an H here, then I want an A, then I want a T. So what is the probability that I reach in and get an H? That's 1 letter is an H out of the 4 letters that are in that box. So you have a 1 in 4 chance of getting an H. Then we're going to multiply. I want an A. And this first one was not replaced, so we're going to mark out one of the letters. We wanted the H, so I'm going to mark the H out. Next, I want an A. There is one A, but now there's only 3 letters left in the box because we did not replace the first one. Then I want a T, and when I go in for a T, there is one T, but now there's only 2 letters remaining. So to find the probability of getting an H, then an A, then a T, you're going to multiply the 3 probabilities together. 1 times 1 times 1 on top is 1. 4 times 3 is 12, times 2 gives me 24. So we have a 1 in 24 chance of getting an H, then an A, then a T. The next question, from box 1, 3 letters are drawn one by one with replacement and recorded in order. What is the probability that the outcome is hat? So the probability of getting an H and then an A and then a T is equal to, and again I'm going to draw 3 blanks just to kind of give us a visual. I want the probability of an H, then an A, then a T, and I will multiply the 3 of those together. So when I want an H, and I'm going to go up here and mark this out, or erase this, excuse me. When I want an H, there's one H in box 1. This is the box we're still looking at. There's one H in there out of 4 letters. But then this is with replacement. So the box is back to its original state. All 4 letters are there. So when I go in for an A this time, there's one A out of 4 letters because all 4 letters are back in with replacement. Then I want a T. There's one T in the box out of 4 letters because we replaced again, getting me back to all 4 letters. So 1 times 1 times 1 on top is 1. 4 times 4 is 16, times another 4 is 64. So we have a 1 in 64 chance. So if you'll notice, the probability of getting hat without replacement is better than getting it with replacement. It's going to happen 1 out of every 24 times compared to 1 out of every 64 times. And so the chances without replacement are better than the chances with replacement. Okay, on part C, 1 letter is drawn at random from box 1, then another from box 2, and then another from box 3, with the results recorded in order. What is the probability that the outcome is hat? So, again, I want the probability of getting an H, then an A, then a T. But now this problem is very different because I'm choosing a letter out of box 1, then out of box 2, then out of box 3. So out of box 1, I want an H. So out of box 1, I want an H. In box 1, there is one H out of 4 letters. So remember, the H, this is coming from box 1, the A, that's coming out of box 2, and then the T, that's coming out of box 3, as described and told in the problem. So out of box 1, I wanted an H, which was 1 out of 4. Out of box 2, I want an A. There's one A out of 3 letters. And then in box 3, I want a T. There is one T out of the 7 letters in the word history. So there's a 1 in 7 chance of getting a T out of box 3. Multiply my answers. I get 1 on top. On the bottom, 4 times 3 is 12. 12 times 7 is 84. So I have a 1 in 84 chance of getting hat when I pull from box 1, then box 2, then box 3. All right, question D, this one's a fun one. If a box is chosen at random and then a letter is drawn at random from the box, what is the probability that the outcome is A? So we're going to randomly choose a box, and then out of that box, we're going to randomly choose one letter, and we want that letter to be an A. So if you think about this, this is multi-stage again, because you're going to choose a box, then you're going to choose a letter. And so if I want the probability of getting an A, there's 3 ways that can happen. It can be that I pick box 1 and then go in for an A, or box 2, then go in for an A, or box 3 and then go in for an A. So when you think about it, it is multi-level, a multi-stage experiment, because you're choosing a box and then you're choosing a letter. And so again, we're going to have to do 3 answers. We've already done this in the beginning of this lesson. We're going to have to do 3 calculations, and then we will add those 3 together. So the probability of getting box 1 and then choosing an A is equal to this. You're going to choose a box, then you're going to choose a letter. So this first probability is a box, and then you're choosing a letter out of the box and you want an A. So the probability of getting box 1 is 1 out of 3. Box 1 is one of the boxes out of 3 total boxes. In box 1, there is 1 A out of 4 letters. So the probability of getting box 1 and then getting an A in box 1 is going to be 1 out of 12. All right, the next thing that can happen, and I'm going to change colors for us, I want the probability of getting box 2 and then getting an A. So again, just like before, it's going to do the probability of getting box 2 times the probability of getting an A in box 2. So there's a 1 in 3 chance of getting box 2. It's one of the boxes out of 3 boxes. If you look in box 2, now you're wanting an A. There's 1 A in box 2 out of 3 letters. So it's a 1 in 3 chance of getting an A if you get box 2. Multiply, and that's 1 over 9. So you have a 1 out of 9 chance of choosing box 2 and then getting an A out of box 2. And then the last thing, we've got to go to our last box. So now I want the probability of getting box 3 and then drawing an A out of box 3. So again, we're looking for the box, and then we're looking for the A in the box. So we have a 1 in 3 chance of getting box 3. It's one box out of 3 boxes. However, in box 3, we have the letters in the word history. There are no A's in the word history, so there's 0 A's out of 7 letters. When we multiply this, 1 times 0 is 0. 0 divided by anything is 0, so this answer is equal to 0. Then we're going to take these 3 answers and add them together. So we have 1 over 12 plus 1 over 9 plus 0, which we don't even need. And we do have to get a common denominator out of 12 and 9. Now, if you had me for 1350, you know that the way that I teach to get a common denominator is to write out multiples of the largest denominator, in this case being 12. So 12 times 1 is 12, times 2 is 24, times 3 is 36, times 4 is 48. And I always suggest writing 4 multiples. I apologize, my phone just rang. I always suggest writing 4 multiples of the largest denominator, and then seeing what is the first one that the smaller one goes into. So 9 does not go into 12 or into 24, but it does go into 36, and so that is the common denominator there. We would need to multiply 12 times 3, and we would need to multiply 9 times 4. So remember, you multiply top and bottom, and that's going to give us 3 out of 36 plus 4 out of 36 gives us 7 out of 36 as our final answer. And that one you're going to really want to study for the test. So make yourself a note of that and make sure you come back and study this entire example. It's a really good problem, but just make sure you really recall how to work this problem for the exam. All right, the last problem we're going to work is, all right, so number 6, there is also going to be one very similar to this on your exam, so I would make sure to study this carefully. The following box has the 11 letters that are shown, which spell the word Mississippi. The letters are drawn one by one without replacement, very important here, and recorded in order. Find the probability of the outcome giving you the word Mississippi. So getting an M first, then an I, then an S, then an S, then an I, then an S, then an S, then an I, and then a P and a P and an I. So we want to know what's the probability that if you randomly reach into this box that has all the letters to the word Mississippi, that you would pull them out in the correct order to spell the word Mississippi, which the chances have to be very, very slim of that happening. But I want to know what is the probability that I get an M first, then I, then S, then S, then I, then S, then S, then I, then P, then P, then I. So, spelling the word Mississippi. So the very first letter I want is an M. So what is the probability that I get an M first? Well, there's one M out of the 11 letters that are in the word Mississippi. And so we're assuming that we get that M, 1 in 11 chances. We take a letter out, and now there's only 10 letters left. Next, I want an I. Well, there are 4 I's, but there's only 10 letters left, and yes, that does reduce. We will work on the reducing once we get to the calculating part, multiplying them together, but for now we're just going to leave that as 4 over 10. And then that letter is gone and not replaced. Now I want an S. Well, there are 4 S's, but now there's only 9 letters because there is no replacement here. So that letter is removed. Then I need another S. Well, now there's only 3 S's, and now there's only 8 letters. And so there's a 3 in 8 chance of getting an S out of what is remaining, and then that letter is removed. Then I would need another I. Now there are 3 I's, but there's only 7 letters left. That's removed. Now I need another S. Now there are 2 S's remaining and only 6 letters remaining with not replacing. Then I want another S. There's only 1 S left and there's only 5 letters left. All right, next letter I need an I. There are 2 I's left and 4 letters left. So 2 out of 4 chance of getting an I next. Then I need a P. There are 2 P's out of 3 remaining letters. I need another P. Now I'm down to 1 P out of 2 remaining letters. And then finally, I need an I, and there's 1 I remaining out of 1 letter remaining. Okay, so now we have to multiply all 11 of these fractions. And so what I like to do is I like to go in and reduce anywhere that's possible. And people do this differently, and so I'm going to switch. Actually, I'm going to switch to a darker color. So you can reduce any numerator with any denominator. And so the first thing I see, the goal is that, we just simplify out anything that we can, and if we can do that all the way through, then the answer that we finish with will already be a reduced answer. So what I recognize is a 4 in the numerator can cancel with the 4 in the denominator. And any numerator, any denominator can cancel, and there's lots of ways you can do this, so don't assume that you have to do it exactly like me, but we should end up with the same answer even if we go through the reducing a little bit different. Like here, I can cancel this 2 with this 2. I can cancel this 3 with this 3. And then let's see what else I can do. I can say 4 goes into 8 2 times. I can say 3 goes into 6 2 times. I have two 2's left on the top, but what I can do now is this 2 can cancel with this 2, and this 2 can cancel with this 2. And everything on top now is now a 1, and so I can't reduce any further. So then I would just multiply everything that's left. So all the tops are now 1s. In the bottom, I would need to multiply 11 times 10 times 9 times 7 times 5. Okay, and everything else is down to a 1. So I would multiply those numbers, and when I do that, let's see what we get. So we're going to take 11 times 10 times 9 times 7 times 5, and that gives me 34,650. So like I said, the chances of that happening were going to be slim. The probability of it happening is 1 in every 34,650 times.